Hello students, we discuss on divergence and curl of a vector function. Before going to know about curl and divergence, let us revise on vector point function. At each point xyz of a region or in space, if there corresponds a definite vector f given as f1i plus f2j plus f3k, where f1, f2, f3 are functions of xyz, then such a function f is called a vector point function and the region is called a vector field. There are many applications of vector fields. Few are mechanics, electric and magnetic fields, fluid motions, heat transfer. Few examples of vector fields are airflow around an aeroplane wing, laminar flow of blood in an artery, lines of force around two equal positive charges. We also discuss on vector differential operator notated by nabla or del equal to dou by dou xi plus dou by dou yj plus dou by dou zk. There are two kinds of differentiation of vector field f. One is divergence and the other one is curl. Vector point function. Let f is equal to f1i plus f2j plus f3k be a continuous differentiable vector function. Then div f notated by del dot f or div f and is defined as dou by dou xi plus dou by dou yj plus dou by dou zk dot f1i plus f2j plus f3k, which is nothing but dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. You can observe that divergence of f or del dot f is a scalar point function. If f represents a velocity field of a gas or fluid, then div f represents the rate of expansion per unit volume under the flow of gas or fluid. A vector function is said to be a solenoidal if divergence of f is 0. Since the derivatives of f when f is constant function, the derivative of f is 0. Constant vector function is a solenoidal vector function. When divergence of f is positive, the expansion is away from the origin. When divergence of f is negative, the expansion is towards the origin. When divergence of f is 0, the expansion is vertical. Vector function. Let f is equal to f1i plus f2j plus f3k be a continuously differentiable vector function. Then curl f denoted by del cross f or curl f and defined as the determinant of ijk dou by dou x, dou by dou y, dou by dou z, f1, f2, f3. When we expand this determinant, we get dou f3 by dou y minus dou f2 by dou z I plus dou f1 by dou z minus dou f3 by dou x j plus dou f2 by dou x minus dou f1 by dou y k. We can observe that curl of a vector function is a vector function. The curl of a vector function represents rotational motion. A vector function f is said to be rotational if curl f equal to 0. We can observe that for the irrotational flow, the flow is as mentioned in the figure A, and for the rotational flow, the flow is as mentioned in the figure B. We discuss few examples of curl and divergence. If f is equal to xi plus yj by x plus y, then find div f. So by separating the I component and j component, we can write f is equal to x by x plus y I plus y by x plus y j. By the definition of divergence of f is equal to dou by dou x of I component x by x plus y plus dou by dou y of j component y by x plus y. So differentiating these two terms and simplifying, we get divergence of f as 1 by x plus y. The other example is if f is equal to 3xyi plus x square zj minus y square e power 2zk, then find del dot f at 1, 2, 0. From the definition of del dot f is equal to dou by dou x of 3xy I component plus dou by dou y of x square z j component plus dou by dou z of minus y square e power 2z k component. Differentiating and simplifying, we get 3y minus 2y square e power 2z. At the point 1, 2, 0, x equal to 1, y is equal to 2, z equal to 0. So we get divergence of f as or del dot f as 0. Show that the vector field f is equal to 2xyi plus xy minus y square j plus x square minus zx k is solenoidal. We know that the vector field is solenoidal when divergence of f equal to 0. So taking divergence of f, that is nothing but dou by dou x of I component 2xyz plus dou by dou y of j component xy minus y square z plus dou by dou z of x square minus zx. On differentiating and simplifying, we get divergence of f equal to 0. So f is solenoidal. Next example is if f is equal to xy square I plus 2x square yzj minus 3y square zk, then find curl f. We know that from the definition of curl f or del cross f, it is nothing but the determinant of ijk dou by dou x, dou by dou y, dou by dou z, xy square 2x square yz minus 3y square z. On expanding this determinant and simplifying, we get curl f equal to minus 6yz minus 2x square I plus 4xyz minus 2xyk. Next example is show that f is equal to sin x plus zi plus cos y minus zj plus x minus yk is irrotational. We know that a vector function f is said to be irrotational if curl f equal to 0. So let us take curl f is equal to determinant expansion of ijk dou by dou x, dou by dou y, dou by dou z, I component that is sin x plus z, j component that is cos y minus z, k component that is x minus y. On expanding this determinant, we get curl f equal to 0. So we can say curl f is irrotational. Another example is show that the vector field f is equal to 6xy plus z cube I plus 3x square minus z j plus 3x square z minus y k is irrotational. Hence find the scalar potential phi such that f is equal to grad phi. We all know that when the vector function f is irrotational if curl f equal to 0. So computing curl f, we get curl f equal to 0. So we can say that f is irrotational. On comparing f with gradient of phi, which is nothing but dou by dou phi by dou x I plus dou phi by dou y j plus dou phi by dou z k, and on comparing ijk components, we get dou phi by dou x is equal to 6xy plus z cube, dou phi by dou y is equal to 3x square minus z, dou phi by dou z is equal to 3x square z minus y. We know that from the total derivative d phi is equal to dou phi by dou x dx plus dou phi by dou y dy plus dou phi by dou z dz. Substituting dou phi by dou x, dou phi by dou y and dou phi by dou z, which is equal to 6xy plus z cube dx plus 3x square minus z dy plus 3x square z minus y dz. Recouping the terms, we can also write d phi as 6xy dx plus 3x square y dy plus z cube dx plus 3x square z dz minus z dy minus y dz. Writing it as a differentials, this is nothing but d phi is equal to d of 3x square y plus d of xz cube minus d of yz. On differentiating, we get the scalar potential phi is equal to 3x square y plus xz cube minus yz. Thank you.